Okay, let's look at how the graph would look different for a graph like 2 over x, so that we can talk about what would happen if we shift it and we'd look at the graph of 2 over x plus 3. Let's make sure we're okay with the graph of 2 over x first. Well, let's start with 2 because that's easy. If you plug in a 2 for x, you get 2 over 2, which is a 1. If I graph 2, 1, I'd be right there. 2 over 4 would be a 1/2. So at 1, 2, 3, 4, I'd be at a half. At 8, I would be at 2 over 8, which is 1/4, which is even, that's 4, 5, 6, 7, 8, 1/8. You can see the tendency of this graph, again, is going to approach the x-axis at an extreme. It's going to get infinitely close, getting closer and closer to 0. As this number gets bigger, 2 over a big number will equal a 0. As I go backward, as I plug in a 1, I get 2 over 1 and I get a 2. So at 1, I'm actually up 1, 2. At 1/2, I would be up 4. And so on. And you can see that the tendency for this graph is going to remain the same as it heads up to a positive infinity. As x gets small, 2 over a small number will be a positive infinity, a big number. You can see the same thing will be true with the negative end of this. At a negative 2 plugged in here, I'd be at a -1. My graph will be that at its extreme, as I pick bigger negative x values, 2 over the big negative value will approach a -0, 0 from the negative side. As I pick smaller values, 2 over that small value will tend to go to a very negative big value down this way. So what's the difference between the graph I just drew and 2 divided by an x plus 3? Well, we used to do this. This is a shift that's happening ahead of time. Just as if I would take this graph and go plus 4, it would just shift the graph up 4, and in fact the horizontal asymptote would change. Here we were undefined that x could not be a 0, but now the new restriction here is that x cannot be a -3. So at 1, 2, -3, I now have a vertical asymptote here. Everything will shift 3 units to the left. So this point that was originally here will now move 1, 2, 3 points here. I will still continue the same behavior, that as I approach the asymptote, I will head for a negative infinity here. As I move away from the asymptote, as I go to very large negative values, I will approach 0 from the negative side. The same thing is true here. At this point, which was 2, 1, has now shifted 3 units to the left. So 1, 2, 3. I will still follow the same behavior, that as I approach very large x values, 2 over a very large x value is still going to approach 0 from the top side. As I approach the asymptote, my values will escalate to a very large number and head out for a positive infinity for the y value. And so what I had as a black graph originally as 2 over x has just shifted to the left 3. The restrictions are that my domain cannot ever include the value -3, and my final graph is the red one. What if they wanted to shift this graph up or down? Well, that would be a value on the outside. If we took the same graph and decided on the outside that we were going to say -1, That means instead of the x-axis now being my asymptote, my horizontal asymptote, it would actually drop down to here. It would shift down 1. So not only would I have backed up 3 to the left, I'll shift everything down 1. And so what will be my new graph? Well, this point, which was just shifted over 3 from here, now is also going to be shifted down 1 unit. And other than that, it will tend to be the same graph. I'll approach 0 from the negative side there. I will still continue to approach this asymptote because the asymptote is at x equaling a negative 3 from the horizontal shift. This red graph would shift down 1 more unit, so instead of just going back 3, I'd also have to go down 1. My tendency will be that it will shoot out at great values of x's. It will head to 0 on the positive side. I will still approach a positive infinity as I approach the asymptote value from the right. So the red graph shifts to the blue. We went back 3 for the bottom, and now we are going down 1. The new horizontal asymptote is at x equaling a negative 1.